Hello students. Today we will be learning about wavelengths and simple harmonic motion and how to solve a free response problem.
There's Matt. He's usually present, at least physically. This is a new low for him.
No matter, I'm sure he'll turn up at some point to receive his extra credit.
Now that's an example of the law of conservation of SAS. Francesca, what is simple harmonic motion?
Simple harmonic motion is oscillatory motion under a retarding force proportional to the amount of displacement from an equilibrium position.
In physics, waves are any regularly recurring event. They are characterized by wavelength, frequency, and the speed at which they move.
Thank you, Francesca. And Krista, thank you for setting up the next problem. Let's look at it. Francesca, will you read it?
A simple pendulum consists of a bob of mass 0.08 kilograms attached to a string of length 1.5 meters. The pendulum is raised to point Q, which is 0.08 meters above its lowest position, and is released so that it oscillates with small amplitude theta between the points P and Q as shown. Calculate the speed v of the bob at its lowest position.
Great. Krista, can you calculate the instantaneous velocity of the object at its lowest point?
Well, we find the initial gravitational potential energy at point Q using mgh because we have the mass, which is 0.085, multiplied by the height, 0.08, and by the gravitational acceleration, which could be rounded to 10. So multiplying these together, we have the gravitational potential energy at Q to equal 0.0664 joules. Since the bob was not moving at this point, this is the system's mechanical energy. Setting that equal to the equation for kinetic energy and solving for plugging in the mass once more at 0.08, we find that the velocity equals 1.25 meters per second.
Excellent use of the energy equations, Krista. Now, the next question reads, calculate the tension in the string when the bob is passing through its lowest point. Francesca, can you find the tension for us?
We can use the equation for centripetal acceleration, which is velocity squared divided by radius. We found that the velocity is 1.25 meters per second, and we know that the radius is 1.5 meters. This gives us a centripetal acceleration of 1.05 meters per second. The total acceleration should be the acceleration due to tension minus the gravity constant. So we add the gravity constant to the centripetal acceleration that we found, and we get the total acceleration of 11.05 meters per second squared. And then we multiply this by the mass, which is 0.085 kilograms, and we get the force of tension 0.939 newtons.
Good work. Last question. What could we do to double the period of oscillation in this pendulum?
Double the length. Actually, Francesca, the length is under the radical of the period, so you actually have to quadruple the length.
That's right, Krista. Today we learned how to calculate the speed of an object and the tension in a string on a pendulum. Thank you very much for learning with us today. I enjoyed learning with you.
Pendulum consists of a bob of mass 0.085 kilograms attached to a string of length
Oh, you.
Excellent use of the